Okay, so we just briefly went over what the mean and standard deviation of a sampling distribution of sample proportions was. Okay, now keep in mind that the standard deviation, if the 10% condition is not met, then we really can't say that this is the correct standard deviation. So remember that the 10% condition is that the population is 10 times the sample size. And that just makes sure that each of these n values are independent and is not changing the probability. So for sampling without replacement, taking one out is not changing the overall probability. So the other thing that you're going to have to check in order to use the normal approximation, this is literally the exact same condition that you had to check to see if the binomial distribution was normal. So as n increases, the sampling distribution becomes approximately normal. Sounds exactly like the binomial distribution. Before you perform normal calculations, you have to check the normal condition. Same, like I said, same as binomial distribution. The sample size times the proportion has to be greater than or equal to 10, and the sample size times 1 minus p has to be greater than or equal to 10. So remember, that's the tipping point between where it's going to start to look approximately normal and not look approximately normal. So really, before you do any of these calculations, you're going to want to state the population's 10 times the sample size in context, and you're going to want to show the numbers plugged into these two to show that you can do normal calculations. Okay, so how can we use the normal approximation for p hat? The inference about a population proportion p, so if we're looking at a population proportion, is based on the sampling distribution of p hat. This can be done so we can use the normal approximation when the sample size is large enough. So if the following conditions are met, then the sampling distribution of p hat is approximately normal. Okay, so I'm going to be talking about conditions in the next couple of sections, assumptions and conditions, and these are conditions for using the normal approximation. Are assumptions that we're making that allow us to use the normal approximations. The first one is np greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Make sure you show the numbers plugged into these formulas, okay? And that's going to allow us to show that the sampling distribution is approximately normal. Same thing as the binomial distribution. There's that tipping point where the distribution becomes normal. Okay, so you have to show that. You must show the numbers plugged into the formula to verify the conditions. Then we can use the normal approximation. So also remember, I said every single time you do a problem, you want to state approximately normally, approximately binomially distributed, approximately, whatever. Approximately normally distributed, in this case, the mean is the population proportion p and the standard deviation. Now notice these are all in terms of the population proportion, p times 1 minus p over n. Well, why don't we use p hat here? You can't use p hat in this formula because think about this. That sampling distribution of p hat has like hundreds of p hats in it. How would I know which one to choose to put in this formula? Okay, so the normal distribution is based off of the population distribution, not off of one single sample. Okay, there's too many samples in order for us to say just randomly pick one to find the standard deviation. Okay, now before you can use the normal approximation, you have to check the following. And I just said this, always check it in context. There's 3 conditions, get used to these. You're going to be using these basically for the rest of the units. So number 1, verify that you have an SRS. Remember that a random sample allows us to make inference about the population. So random samples allow us to make inference, and they also help to reduce variability, okay, and hopefully get a unbiased estimator of the population. Check that the distribution is approximately normal, okay, show the numbers plugged in here and here, greater than or equal to 10, and then verify the 10% condition for independence. You have to have this verified to use for the standard deviation. So you can just say, I always do it. I do like, if the sample size is 10, I would do, or sample size is 20, I would do 10 times 20 equals 200. There are more than 200 students in Fairfax County, so you want to make sure that you put that in context, okay? If one condition is not met, all right, then you have to state, we're proceeding with caution. We're not sure whether these calculations are correct or something. So you're sort of warning the leader, or the reader, hey, I'm going to do these calculations, but I'm not really sure if they're correct or if they're going to be good for inference about the population. Okay, so just a quick summary. Number 1, the parameter p is the population proportion. In practice, this value is usually unknown. If we know the population proportion, there's really no need for a sample. The statistic p hat is the sample proportion that you get. We use p hat to estimate the value of the proportion. the value of the statistic p hat changes as the sample changes. So that's why we use the population proportion when we're doing our calculations for the mean and standard deviation. Okay, and then you might also say for this one, well, if p is unknown, like what are we going to do? So we would know p or estimate p after we've taken a look at the sampling distribution and found the sampling distribution of p hat. That would be what we would assume would be the population proportion. Okay, in this case, almost every single time you're going to be given the population proportion. Okay, and then how can we describe the sampling distribution for p hat? All right, number one, the shape is approximately normal when the sample size is sufficiently large. So that's when you do np greater than or equal to 10 and n times 1 minus p greater than or equal to 10. The center is described by the mean, so the mean of the sampling distribution is the same as the population proportion. The spread is the standard deviation, and keep in mind that as the sample size increases, since it's in that denominator, the standard deviation is going to decrease. Okay, if our sample is a simple random sample of size n, then the following statements can be made to describe the sampling distribution for p hat. Number one, the shape is approximately normal. Okay, so this is when you've done the conditions. Okay, this is the assumption and the condition. We have an assumption that the sample is large enough and we have a simple random sample. Show the condition np greater than 10 and n times 1 minus p is greater than 10. Read the question carefully to make sure it's stating that it's a simple random sample. Then the mean of the sampling distribution, the mean of p hat, is the same as the population proportion. Okay, the standard deviation is always going to be p times 1 minus p divided by n. You might see q here. Q is the same as 1 minus p, but also keep in mind that your 10% condition has to be met here to show that each of those n values are independent. Okay, so that's where your population is 10 times the sample size. Now, the mean and the standard deviation formula are on the AP exam formula sheet, so be able to recognize what those formulas are, and if you forget them, know where to find them. All right, so let's do an example. Okay, so a polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students actually attend college within 50 miles of home. What's the probability that a random sample of 1,500 students will give a result within 2 percentage points of the true value? Whoa, okay, so here's the question. How do I know this is a sampling distribution and not just a regular normal distribution question? You have to look at the last sentence very carefully. What is the probability that a random sample of 1,500 students, so what that means is I have a graph with a whole bunch of different p hats from 1,500 students, okay? So that tells me that I'm looking at a sampling distribution and not a population or just a sample. All right, now, before you do anything, you want to do your state, plan, do, conclude. So this is your state. What are you doing? Planning, showing your assumptions and conditions, what work you need to show, and then your conclusion. All right, so what exactly are we doing? We're finding the probability that the sample proportion falls between 0.33 and 0.37. Well, how did we get that? So suppose we know that's our population proportion, that 35% of all first-year students attend college within 50 miles of home. We want the results within 2 percentage points below and above, so that puts it between 0.33 and 0.37. Now, before you do anything, you have to show your conditions and assumptions. Number one, it says we have a random sample of 1,500 first-year college students. Now, our conditions are NP, so 1,500 times 0.35. Notice how I showed the answers, okay? And then notice how I showed the plugins, 1,500 times 0.65, okay? Both are greater than 10, therefore it's approximately normally distributed. Make sure you use the word approximately because it's never perfect. And then this is your independence condition right here for your standard deviation. There's most likely more than our sample size, which is 1,500 times 10, which is 15,000. There's most likely more than 15,000 first-year college students. It's independent. I can use my standard deviation formula. Okay, the next thing you want to do is show your work. All right. You can just do this portion right here, but show your work for your plugin for the standard deviation. So it's approximately normally distributed. The mean of the sampling distribution is the same as the population proportion, which is 0.35, okay? And the sampling distribution to get the standard deviation 0.35 times 0.65. The 0.65 is 1 minus 0.35 divided by your sample size, 1500. Make sure you take that square root to get 0.0123. Okay, now notice this statement right here. What was the question asking us? What's the probability that a random sample of 1,500 students give a result within 2 percentage points? So this probability statement, notice it's not p, notice it's p hat. What is, if I'm looking at this curve and I have a whole bunch of different p hats in here, all of these p hats are 1,500 students. So if I pull one of those p hats out of there, it's going to be a p hat from a sample of 1,500 students. So this is saying if I take one of those samples of 1,500 students, what's the probability that that one specific, that one specific p hat that I'm pulling out there is between 0.33 and 0.37. Show the z-scores, work for both of them. You have your mean and standard deviation, so this is not new. Okay, z-scores, the probability now between your z-scores, use your calculator to find that answer. Okay, and that's, the rest of this is not new. This is all stuff we've done in the past. Okay, so please make sure you note for your homework assignments, tests, quizzes, whatever, all work on this slide is necessary. You need to show the work for the mean and the standard deviation. Not too much work for the mean. Show the plugins for the standard deviation. Show this probability statement with p hat that tells us that we're looking at a sampling distribution. Show the work for the z-scores, and then show your probability statement with your z-score. Don't give me any calculator speak because every calculator has different ways that they show how they arrive at the answer. Okay, so this one, and then the next one is just your conclusion. So just giving me your answer of 89.68% of all simple random samples of size 15 will give a result within 2 percentage points of the proportion of college that attend within 50 miles of home. Okay, so what's the probability? So that gives us 89%. Okay, so what does it mean in the last step if you get a high probability of the event occurring? What's the difference between that and a low probability? So with a high probability, okay, so this is going to become important later on. There's a high probability of that occurring. So there's a high probability that between 33 and 37% of students live within 50 miles of home. That's saying that's like pretty often. So when there's a high probability, then it happened by chance alone. It's not significant. It's basically saying a lot of people live close to home. It has a high probability. It's very normal and it happens all the time. If you have a low probability, then that's basically like saying it didn't really happen by chance alone, and we're going to be going over this later on, but low probability means that it's not really that normal. It's not normal to occur that often, so something might be different than what we think if that probability of something occurring is very, very low. And like I said, we'll get into that later on, but low probability means it didn't happen by chance alone, and because random chance is going to give us various probabilities, and if it's a low probability of happening, we're going to say, ooh, it has a low probability of happening, but it did occur, so what does that really mean? Is there something else going on? Okay, so go ahead and take a minute, read this one, and then I want you to hit pause and check your answer on the next couple of slides. Okay, so hopefully you recognize that this was a p hat. How did we know? So what's the probability that an SRS of size 125 will give a result within 7 percentage points of the true value? Okay, so SRS of 125, you're going to think about a curve with a whole bunch of sample proportions of 125. What's the probability that one of those are going to give a result within 7 percentage points of the mean? Okay, so here's our 7 steps. This is what you're going to need to show. I know it seems like a lot of work, but you get used to it now, and it's much easier when we do inference. Here's our state. We're finding the probability that the percentage of middle school students who plan to attend college falls between 73 and 87. So within 7 points means 7 below or 7 above. Here's my assumptions and conditions. Simple random sample of 125 students. Notice that is in context. I did not just say SRS. Here's your conditions for your normal assumption. Make sure they're plugged in, and you make the statement, therefore the distribution is approximately normal. The independence condition, we assume that there's more than 12, notice how it says 10 times 125, or 1250 middle school students. Notice I'm stating, therefore it's independent. We have the mean of p hat is 0.8, and notice I show the plug-in for the standard deviation from the sample, 0.8, 0.2 divided by 125, 0.036. we're checking to see, notice the p-hat statement, that one of those samples of 125 students falls between 73 and 87%. Work probability statement with your z-score, answer, and then final answer as a sentence.